All right. What is this? The third? Uh,
Fourth, I think.
the fourth of our videos. So, welcome everybody. This segment, we're going to talk about the voting process using distributed computing. And this is the fourth video where we're going to actually start talking about the high level solution architecture, where we're going to dig a little bit deeper and talk about how we would actually build this solution out. All right, so let's get into it. High level solution architecture. Um, we have some visuals that you're probably seeing, and Eric, we've talked about where we have two networks, right?
Yes.
So we have the open network, the closed network. What do you call them? You have your words from,
Yeah, the institutional system and the popular system.
okay? And if you look at the illustration, essentially it's the same application, but two instances running in parallel, yes?
Yeah, they have some differences, but they're essentially the same functionally as how
Right.
they work.
The difference is that the institution has their version so that they can do their what would be the specific things, the tallying portion, the assessment portion.
Well, so the way that the system works is agnostic from the concept of voting. It basically runs all of the processing that you would have for any bureaucratic system. And so it's associated with bookkeeping, essentially, and data and everything associated with that.
All right, describe to me. So we have the open network. Let's start getting into some of the nitty gritty of this. So we've talked about identity. So the person has their address now and they're about to go vote. So they're going to use some sort of system, whether it's their phone, perhaps, yes, their PC, or if you have no technology, you go to a library or some institutional controlled environment that's sterile and supposedly not influential at this phase. But is that the kind of idea?
Yeah, so it's anything that's connected to the internet, essentially. Anything that's connected to the internet, or basically anything that has, network capability.
So phone anything, so they can use the address, place their vote for their candidate. It gets put into the network's ledger,
Yes.
and the ledger is being constantly updated from all these different sources. And so now we go into the inner workings of this is transparent so that everybody knows what's going on.
Yes.
Then what happens? So there's a vote. It's cast through this blockchain. What's next?
Well, the agreed upon things beforehand were the parameters for what is considered a vote, a proper vote.
Right.
And so everybody knows the parameters, so basically whatever the results are instantaneously, or however long it takes to process the chunks associated with that, and if there's a cutoff point, that cutoff point, everybody can basically see.
So basically, we've gotten to the point where we've cast our vote.
Yeah.
We'll go to what? Tally. Yes?
Yeah. So that there's no real tally process. It's essentially,
It's continuously happening, right?
well, yeah, everybody knows.
Yeah, everybody's seeing where the votes go because it's in real time. But the tally process essentially prepares itself, or is preparing continuously to communicate or to be communicated to from the institutional network.
No. So because it's a twin network, everybody knows.
So it's continuous. The exchange of data is continuous.
Yeah, it's a twin.
So that's what I'm saying.
Yeah.
So all of this stuff is happening in the public network. The stuff is being captured. The votes are being captured, and then we get into a situation where continuously these two networks are chatting back and forth.
Yes.
And the ledgers are being updated. The actual accounting portion of this, where describe for me your vision on how the vote is actually routed to the candidate.
So the because of these two pairs essentially of peers, like it's a twin system. So there's a record essentially for each person on the institutional system, and then as well as the popular system, based off of any information of the two, which are paired. There is a pairing process, but once that is done, essentially people can track the validity of any
So-
kind of
So would it be fair to consider this almost like an exchange? So currency exchange,
Yeah, well, essentially, so you're essentially like have a ticket, and then you're depositing that ticket with whomever candidate.
right? So in another way, this is actually better, open, and fair to the candidates. There is no deception that they can point to, right? Because if it votes for them, there is no ambiguity. It's gone to them,
Well, it's tied directly to them,
right?
and people may get votes that they may look at and say, okay, well, this is not a legitimate vote, but we've already agreed upon beforehand, before the election process.
Why would they do that?
Well, that's part of the election process.
Right, so the whole point of this is that that's not going to happen. It shouldn't happen because we've agreed upon certain incentives that the network intrinsically has to prevent or let's say reduce and get to a point of almost negligible fraud or deception.
Well, let's give this as a hypothetical.
Okay.
Let's say everybody wants to commit voter fraud. Everybody on the network, just as a hypothetical. They would essentially, every single time they establish a contact with the institutional network where that contract is signed, and that being a proof of their existence and a legitimate person, essentially they would try and create a double record. But because there is no redundant record in the system, you can't have redundant records or redundant ties. There's no way for that to actually happen. So you could still cast your vote, but the agreed upon methodology that people will look at and say, this is a legitimate vote. These are the terms of this legitimate vote. And anything that doesn't meet that criteria isn't legitimate.
This goes back to the concept that we were talking about before, where you can try and build up defenses against hacks and vulnerabilities. However, if you just account for identifying things that are anomalous,
Yes.
it makes it you're much stronger. So acceptance is better than denial.
Yes, and so all these votes may be cast, but only the ones that were part of that criteria will actually
the real
sort
ones,
through. Yeah.
the real ones.
Yeah.
No.
So everybody could try and commit voter fraud, but it wouldn't actually be counted.
So a couple of the things that we've got to consider. This is the hard part. This is identity was one of the hard parts. This is the second and third, perhaps, if you want to separate them, but really the second hard part. It's the incentive models. The incentive models for both the open network as well as the institutional network or the closed network.
Yes.
What's the incentive for these two systems to exist, first of all? And then what's the incentive model to prevent people from diluting the networks?
So
that's a hard one to answer.
That's a very difficult
because
question.
There's a lot of answers, and which one is the right answer, we don't really know at this point.
I think one thing that is important is to actually mix the two networks. Having it where whatever machine is running this whole process as a miner is not it can't discriminate against what is and what isn't the potential record counting mechanism. So essentially they would see the institutional version and the popular version as the same. They would have no, it would be different, it would function differently, but it would be the same.
Well, let's say instead of saying function differently, I think the environment for its functioning would be different. I think that's the best way to describe it, because technically it could be somewhat similar, but yes, it would be these two networks, right?
Yes.
Go on.
Yeah, so it would be functionally two networks. And again, with that pairing, there is no part of the process in which someone could discriminate.
Right.
There's even from the individual just interacting with another individual, the contract itself has basically been pre-drafted. So any interaction with them is within the contract, and if they break that contract, it's demonstrated throughout the entire record process. And so it's a permanent record for that instance, even in that individual record.
Right. You could the whole point of this is you're never going to be smart enough than everybody else. So
Yeah.
somebody's going to come up with a better idea to hack your system or
Yes.
break your system. So it's better to allow for and give room for people to hack, but for you to be able to know that they are hacking, have hacked, or what did they affect.
Yeah, there's no way that you can prevent a certain level of, I don't know, just amount of contact. It's just how you deal with that contact.
Very good. Very good. So we're at the end of that topic. This is the final piece. So we've hopefully we've covered for you at the level that we can without spending countless hours of going into the nitty gritty of this, how we're envisioning this system to come together. So really we're transitioning into, and in this episode we're going to review what we've been talking about. And really we talked about creating a fair, free, and open election system. And the concept of distributed computing, we talked about all of the pieces that will give this system the integrity that we all hope for all elections, including the one that we're experiencing now. So the two big pieces that we covered here was capture and tally.
Yes.
That's really what everything that we talked about covered. So let's summarize the capture part, Eric. So we've got two different networks. Those two networks are going to somehow give an address to individuals. The people who have those addresses can use it to cast their votes, right?
Yes.
And in real time, those systems are going to be tallying the votes essentially,
Yes.
right? To feed into the tally phase. And in the tally phase, there's a process of both validation
Yes.
as well as accounting.
Yes.
You want to go into any of those pieces further and give more insight as a review part?
Yeah. So the thing is, essentially the way that these systems are working is not as a client server relationship. They're working as if the network itself is a machine, one monolithic machine, and this is one application that we are all collectively sharing as a network, and we're collaborating to use that. So because of that and that collaboration, there's certain things that we can do because it's technically one application where any one of us can look and see the data. But the institutional system and the popular system basically says, okay, there's a separation of concerns here. This record associated with this person associated with government record, we're going to hold, but nobody else can see it. They may have the key essentially to see that data. So, in theory, somebody could subpoena and say, okay, here, let's look at this data, but nobody else can look at it, even within government hands. The popular system is the other way around. It's essentially a system where we hold a record and the institution holds a key, and we have to give them that block of information. That is the vote. That is the piece of information that quantifies a vote, and it is unique to the individual. So if somebody wants to, counterfeit that, that's not something they can just do.
And even if they try and do it, it becomes very apparent that they did.
Yes, because
The whole
there would
trail
be
of it wouldn't be there.
well, there would be two records,
Right.
and that would invalidate the process.
Well, hopefully everybody enjoyed these series of videos. Apologies for some of our looseness in this. This is our first set of videos. We're still learning. I'm much better than Eric at it,
course,
but
yeah.
we're still learning. We'll get there. Any feedback, positive and negative, is always welcome. Negative helps us learn. Positive makes us feel better. So hope to see you guys in the next couple of videos. Thank you all for watching.